In this video, we are going to practice almost everything we've learned about rational functions. So let's get started. Here we have the function, a rational function that hasn't been simplified yet. So you guessed it, we're going to factor. Let's start by taking out the negative from the top. So we get negative x squared minus 9. And the denominator, what multiplies to 12 that adds to 7? That would have to be 4 and 3. Let's keep going. We can factor the top further into negative x plus 3 times x minus 3, which is great because that means we can reduce it. We have a whole. Okay. But let's do ourselves a favor and let's keep track. We know that negative 3 would make this become 0. So let's write that down for later. We just don't know what the y value is going to be. All right, let's start with what we always start with, the vertical asymptote. Let's use our reduced function. So I have negative x minus 3 over x minus 4. Okay, if I look at the denominator, 4 will make it equal 0. So that's where our first asymptote will go. For horizontal, we have the same exponent, and that means we'll use the coefficients out front, which would be negative 1 over 1 or negative 1. Okay, so y equals negative 1. There we go. Let's go ahead and find the x-intercepts. All right, if I look at my reduced function, I'll set it equal to 0. Remember, we only look at the top. The bottom's going to go away. So I get negative x minus 3 equals 0. If I divide by negative 1, I get x minus 3 equals 0. Add the 3 over, and we get x equals 3. So when x is 3, y is 0. And let's plot that as well. 3, 0. All right, let's go ahead and get the y-intercept. We'll plug in 0 for x. And then we'll simplify. So I get 3 over negative 4. Okay, negative 3/4. When x is 0, y is negative 3/4. 0, negative 3/4. So we can see our curve starting to form, which means that we should have a curve over here. Let's go ahead and write down our information as well so we don't forget. Okay, we do need to find the whole, so let's do that next. I already know the x value, negative 3. So that just means all I need to do is plug it in. Negative 3 minus 3 over negative 3 minus 4. Okay, so I have negative 3 minus 3, which is negative 6, but then I have a negative out front, so that's positive 6 over negative 7. So the whole is at negative 3, comma, negative 6/7. Negative 3, negative 6/7. So we've got a whole right here. Alrighty, let's go ahead and get 2 more x values. Let's do x equals 6 so that we get something down here in this part. All right, so if we plug it in, that's negative. We have 6 minus 3 over 6 minus 4. Okay, so 6 minus 3 is 3, negative 3. 6 minus 4 is 2, so negative 3 over 2. 6 negative 3 over 2 is right there. Let's go ahead and do 5. If I plug it in, I get negative 5 minus 3 over 5 minus 4. Okay, 5 minus 3 is 2, so negative 2 over 1, which is negative 2. 5, negative 2. That's enough to make a curve. let's talk about the domain. We can look at the graph, and that helps. And we can also look at things algebraically. Remember, the things that affect the domain are holes and vertical asymptotes. Our domain is going to be every single number except for the x values with the hole and the vertical asymptote. So x cannot equal -3 and it cannot equal 4. For the range, that is going to be affected by the horizontal asymptote and the holes. So the y value of the hole and the horizontal asymptote. Y cannot equal -6/7 or -1. It can be everything else except for those values. For increasing intervals, remember you trace the graph with your finger going left to right. And it's really hard to tell, but here it is going up and then it's really going up slightly. So this side is increasing. It's increasing everywhere to the left until we get to 4. So from -infinity until 4, our graph is increasing. Then, if you pick up your pen from here and then pick up down here and trace it again, you'll notice it's still increasing. It just skips at 4. So it actually increases from 4 to infinity as well. And you'll also notice that no matter how many times you trace it going from left to right, it's never decreasing. So we don't have a decreasing interval. This function is always increasing. Takes practice, but stick with it. You've got this. Thanks for watching.